Here's our second example. This is in the style of a classic exam question. So you're given the value of one trig function, okay, and we're given a range of values for the angle, and we have to find the exact value of a different trig function, and one here. Okay, now you might think you could use your calculator and just do like inverse tan of 15/8 and then sine it, but if you do that you'll get a decimal. It'll give you a good check for your answer. You can check that your answer matches that, but we're asked here for finding the exact value, and so that means we have to show our working out. Okay, so let's start with the information we're given. So cot theta. Now we know that cot is 1/tan, and tan is opposite over adjacent, so cot is adjacent over opposite. Okay, I can use that information to draw a little triangle. Okay, I'm going to pick an angle in the corner there. And so my adjacent side will be here and my opposite side will be there. I'm ignoring the sign at the moment. We'll deal with that after. So now if I do 8 squared plus 15 squared, that gives me 17 squared, so we get 17 on this side. Okay, so now I know the value, the size of sine theta, because that's opposite over hypotenuse, 15/17, but I don't know if I should have a positive or negative value. So to help me decide, I draw a cast diagram. Remember, the letters represent which of the trig functions out of sine, cos and tan are positive in that quadrant. We measure all angles from the positive x-axis, and we're told that our angle is between 3π/2 and 2π. So we go around, there's π/2, there's pi, there's 3π/2, we keep going to 2π, so somewhere in this region. So I'm going to draw my stick there. I always draw the angle made with the x-axis. Okay, so in this region we can see that the only thing that is positive is cos. So that tells us that sine will be negative. For our second part, we want sec squared. Now that's good news. Having a square means that the sine will be positive. We just have to remember that sec is 1/cos. Cos is adjacent over hypotenuse, so sec will be hypotenuse over adjacent. I made a mistake over here. Okay, now looking at our triangle, the adjacent is 8 and the hypotenuse is 17, so we have 17/8. So when we square that, we end up with 289/64. Okay, so that ends part A. The second part of the question is quite similar. Okay, slightly different information. So we're given that cosec is -7/6, and we're also told that tan theta is greater than 0. We're not given the range of values for theta. We have to find cos. So let's start from the information given. So we know that cosec is 1/sine, and so that means it will be hypotenuse over opposite. So I'm going to draw a little triangle and put that information on the triangle. So I'm going to use 6 for my opposite and 7 for my hypotenuse, and I'm ignoring the sine again. So if you do 7 squared take away 6 squared, you get 13, so this will be √13 on that side. Right, we have to find cos, so we know it's going to be adjacent over hypotenuse, but we need to know what the sine is. So again, I'm going to do a cast diagram to help me decide. Okay. Right, so measuring from the positive x-axis, going in the positive direction, I know that cosec is negative, all right, and I also know that cosec is 1/sine, so that tells me sine is negative. Now the A means all of them are positive here, sine is positive there, so it must be one of these two areas that we want. So sine is negative in those two quadrants. Then we're also told that tan is greater than 0. So tan is greater than 0 in the all are greater than 0 zone and in the T zone. So this is our overlap. So we know that our angle must lie in this quadrant. Okay, And we know that in this quadrant, the only thing positive is tan, so cos is negative. So if you're a graph person, it's a bit more of a palaver for this one, but it still works. So we start by thinking about cosec being negative. So cosec is 1 over sine. Okay. And so we can see that sine is negative for this range of values here, from pi to 2 pi. Okay. And then we need to think about tan being positive, as we're told. So we can see that tan is positive in this zone and this zone, and then we can see that they match up between pi and 3 pi over 2. So we want to find out, is cos positive or negative in that region? Okay, so we are now looking at this bit here, and we can see that cos is indeed negative.